Everyone, to the first of our fall 2023 lectures. And our guest speaker today is Dr. Hamid Mostofi. And Brian will introduce him in more detail in just a moment. I'd like to go over some of the logistics of our lecture today. We are on Zoom and live in person and are currently recording this lecture for to post on our website at a later time. Advance my slide. The lecture will last approximately 50 minutes. We will preserve about 10 to 15 minutes at the end of the lecture for questions and answers. We like to wrap up 10 minutes before the hour because a lot of students have to get to the classes and faculty have to get to the classes at 1. If you're participating in Zoom and you have questions for the speaker, please put that in the chat box and Brian will review those or sort of triage the questions in person and online. And please keep your audio muted while you're in the lecture. And I'm going to turn it over to Brian now to do the introduction.
All right, thanks, Jane, and welcome everybody. It's nice to see you all. I'm Brian Bedoli. I'm a lecturer. I'm in the Master's of Real Estate Development program. It's my pleasure today to welcome Dr. Hamid Mostofi. I actually just hosted a study abroad on behalf of CAPLA in Berlin, Amsterdam, and Paris this past summer. And I had the pleasure of meeting Dr. Mostofi there. So we decided to import his lecture here so you guys could all enjoy it. So I really appreciate y'all coming. And please help yourself to food. We're kind of constrained on time, so without further ado, I'll let you introduce yourself. I don't think there's a better person to do that. And I'll pull up your presentation here for you.
I think that maybe the presentation. Great. Yeah.
There you go.
Perfect. Oh, thank you so much. Really appreciate it. It's a great honor for me to be here, and thank you for having me, especially on these days that in Berlin is a very cloudy day. And I'm really impressed when I have this direct sun in this college town city. Anyway, really appreciate for this time. And yeah, the topic is system dynamic modeling for sustainable urban planning and development. Just have a quick introduction from my side. Yeah, in Germany we have a very big, actually, prefix. I mean, the Dr. Field Diplom in MBA, but it's a kind of the military actually the grades that for each grade, I mean, that we get some title. But I am a project manager and senior researcher at Technische Universität of Berlin, and at the same time as a professor of data science and artificial intelligence at SRH Berlin University. Mainly, I have a Technische Universität of Berlin. I mean that the German system is that as the biggest technical university in Germany is a kind of the R&D for ministry. So because I mean research and education system in Germany is a very governmental system rather than the private sector. So mostly actually our research and fund it comes from government and the public fund, and mainly, for example, in my profile, I work and now I have been working on 4 federal projects, such as e-haul electrification of long-haul heavy-duty commercial vehicles with automated battery swapping station. This actually is from the Federal Ministry of Economy Affairs and Climate Action, I mean the Bundesministerium für Wirtschaft und Klimaschutz. And we are working on this case that that if we want to electrify, if we want to have a zero emission or green transportation system, for example, in Germany, the big share, the CO2 emission comes from the commercial part, especially heavy trucks and such as. So imagine that if we want to electrify heavy truck, when we are talking about the 1 megawatt battery capacity, or for example, 600 kilowatt battery capacity, by the normal fast charging infrastructure, it takes maybe, for example, 1 or 2 hours. And it takes so much time for the commercial sector if they want to spend 2 hours for charging this case. So the technology that now we are working in Germany is a battery swapping. But my work is that if we have a new technology, for as a sustainable technology, how we can guarantee the acceptance of market and stakeholder. So I mean that although you have a technology, but how you can sell this technology or convince different stakeholder that to use it. Yeah, this is a completely two parts. I mean that honestly, in terms of the technology right now, I mean that the technology or technical aspect is not big issue, but the acceptance of the logistic part is a big barriers or some problems here. So this is a project that right now I'm working here in Germany. Also, I had some project before, for example, smart urban mobility by considering climate change. It's from the Ministry of Education and Research, Green Energy Center. I'm the member of the Green Energy Center in Ministry of Environment. And also another topic is Mittelstand Digital Centrum. It's a digitalization and application of AI in the tourism industry. That also is a part of the project. So I have also the local project in Berlin and Brandenburg, for example, citizens' response to sustainable mobility and infrastructure scenario for Berlin, and then also some project for New York, Cairo, and Tehran before that. So now I am right now visiting a scholar at UC Berkeley, and I work on my topic that I work in UC Berkeley is the participatory UX design for taxi air to maximize public acceptance. This is a project between UC Berkeley and NASA to run the taxi air as a eVTOL, electrified vertical takeoff and landing vehicles. And but again, the question is that how we can design as a UX is a user experience, how we can design the user experience to have a more share of stakeholders and more acceptance of people. So what about the topic today? I want to give lecture. I mean that with these three components or three parts: system thinking in urban planning, and introduction of some quantitative method or simulation methods such as system dynamics modeling and machine learning that we can use for this case, and also case studies of this actually application of these methods. It has two parts. The first part, I introduce just the topic. The second part, I will go in depth and explain more in details. But learning thinking versus system thinking, this is the first step. I think that when we are talking, I mean that mostly for urban development project or decision maker or policy maker, we have the method of thinking as a linear thinking. So linear thinking, I mean that is like that if there is a problem, there are some reasons or causes, but the relationship between this cause and effect is very straightforward and very direct together. And honestly, I mean that this is the method that we have been taught also in the schools, because if there is a problem for teachers or for education system, it's very easy to say that, hey, this is the reason of this problem. Just making a very complex system, I mean that the different aspect of interaction or interrelation between these causes is not really easy to teach even in the schools. So because of that, we have more this linear thinking method, yeah? And in policy making, I mean that this is that fishbone method, but it's a very industrial method that if something happens wrong, you have to classify, for example, this problem or reasons or causes of this problem in, for example, 6 categories. Or, for example, in production line, for example, we have a 4M, man, machine, material method, or a little bit more advanced, such as, for example, mother of nature, it's the environmental problem, or measurement, the control method. So if you look at this case, if something happens wrong, or if you want to find a solution, then you find that, okay, what type of the categories which are really separated to each other, and how we can categorize the reasons or causes of this phenomenon, yeah? But in system thinking, we are thinking in a loop way. So we said that, I mean that all of you know about the Newton law, the third Newton law. Who remembers the third law of Newton? Just it's from physics. Action and reaction, if you remember. So if you hit the wall also hits you as well in a completely opposite direction. Yeah, it's very easy. I mean that, but normally how we can, I mean, if there is a one cause, this cause or this factor is not isolated from the others, and they are connected to each other. And we have the interaction and interrelations between some causes together and between them with the result. Yeah. So let's have some example to think about some practical examples. So e-micromobility, such as e-scooter, are they sustainable or unsustainable? I mean that yesterday night, I had a very quick excursion and walking around the campus, and I was really shocked. I mean, oh, a scooter is forbidden in this area. I mean, that is very interesting. I took a photo, sent to my colleague in Berlin, said that, hey, this is the time, you have to see something. So very interesting. But now, look at this actually example. I have one question. E-scooter such as this, it is motorized by electric battery. So actually, when you think about that, there is no CO2 emission, yeah? Because it is electrified. Now, my question is that, do you think if we use this very micro, small, green, fancy scooters, do you think that in terms of CO2 emission, does it have positive impact or could be negative impact? Why?
All the resources you have to mine to make all of those batteries and stuff.
Oh, okay. Just the production of the battery, you mean? Or after that?
The whole thing.
Yeah. So good point. 1 point. What about the others? Just as a 1 point, let me to give you some result of surveys in. Look at that. 2019. Even the situation could be more worse. So I think that this is in Denver. The early surveys asked the regular users of scooters, said that, hey, before scooters, e-scooters such as Lime or Bird in Germany, for example, which mobility mode did you use? Or for example, it's a kind of the question that which mobility mode have been replaced by e-scooter? And some results, just look at that. 57% said that e-scooter sharing trips replaced walking, 43%, and biking trips. So imagine that in Denver, 57 of users, before that, they walk and only use the non-motorized mode, which is, if you look at that, they are really green energies. There is no emission. Of course, there is emission, but this energy is not that. But electrify, I mean that San Francisco, 61% replace non-motorized mode by electrified mode. And then look at the electricity profile of United States. Because if you look at that near to 62% of electricity is generated by natural gas and coal, plus nuclear power is almost 82%. So 60% in San Francisco replace walking by scooters, electricities. It means that this trip could have been done by walk, not by electrified mode. And we are talking about the country that near to the 62% electricity is directly coming from fossil energy. So this small little fancy electrified transport mode, actually they are indirect CO2 generators, because people replace and change their mobility behavior, shifted from the non-motorized to motorized, and this electricity is coming from the CO2 fossil energy. If you are talking about Norway, by 99.5% electricity is coming from renewable energy. I don't care, people replace it. Okay, maybe it's a health problem or issues that they get lazy. But in terms of CO2 and in terms of sustainability, it's also in Germany, the result is not very good. Now, then another question, and then I come back about the system thinking, how we can think about that to avoid this kind of the rebound effect. Because the main idea of e-scooter is replacing of cars or private car or fossil fuel car, for example, by electrified modes to have a better society and green environment. But rebound effect actually avoid that. So we have some method to think about that and to solve. Another question, if we make or add capacity to the road or network, or for example, autobahn, could we solve the traffic congestion problem or not? I think that one of the good cases is also about Arizona. I mean that in 1990, it's a very classical example that we use in Germany. I mean that in my class, in 1995, 1996, there was a big project between Phoenix Airport and Queen Creek as a downtown of Phoenix. And too much, I mean that expended too much money, millions, just to expand the road and capacity of that instead of the 2 lanes, for example, 4 lanes or 6 lanes in each side. And all people are happy, laughing of that. Maybe I can move this. Very good development policies. All people are happy. And then after that, not happy, because again, traffic congestion came back even more worse in a rush time. Yeah. So the question is that we spend lots of money. We widen and actually broaden the autobahn to solve this physical plant, because linear thinking said if we have a traffic congestion means that the physical capacity and the number of cars, they are not matched together. And because of that, car cannot move and we have traffic congestion. So if we provide more place, it's also we can solve the problem. But because of some other factors, that if you provide more place, also you increase the utility function of using car. Or I can say that actually by decreasing of travel time by car, indirectly you encourage people to use their car more. So this is, although the physical play as a straight linear thinking means that there is no space, provide a space. But system thinking said that, okay, you change the setup by providing the time, then the behavior of consumption also changed because of the interrelation between behavior of consumption and also the physical space. Yeah. So this is a linear thinking, system thinking. So if you build them, they come. So I mean, that pictures from, I think that in China is a parking spot in Beijing. Just imagine that how much cars are there. So now, in sustainability, we have the topic of Jevons paradox. Jevons paradox, I think that I can, yeah. Jevons paradox said, I mean that in 19th century, I mean that this is the idea. So have you ever heard about the Jevons paradox? So this is the new topic of the school of, I mean that sustainability school or sustainable economy school that we have to think about that. In 19th century, you know that this is a revolution, industrial revolution time, and the industrial revolution time is mainly based on a steam engine. The steam engine at that time, they work by coal, just to burning coal, and then changing, for example, water to steam, and then generate the movement, yeah? So coal was the strategic energy resource at that time. So then something happens, because always economy benefit move and push scientists to make a better engines and technology advancement. Then actually the market at that time had a new technology to more energy efficiency, by less energy generates or produce more, for example, textile or outcome, yeah? So we have a big energy efficiency at that time, at the 19th century. In the beginning of this year, all of the economists said that, hey, we should not import too much coal because the market demand decreases. Because of this new technology advancement, we require less coal, yeah? But the result is completely different. The result is like that, if I can go to the next. This Mr. William Stanley, he was the youngest, or he was an economist at that time in this company he worked, and he said, no, because of the technology advancement, the profit margin increases. And when the profit margin increases means that by less energy or by less input or cost, you can get more profit. Now, the market said that, okay, this is a time that I can get loan from bank, because my efficiency higher. So if I consume more coal, I can generate more benefit or profit. You understand? So although if you think linearly, that say that, okay, we need or require less coal, but markets say that, okay, less coal with the same output, it means that more profit, it means that I can take the risk of the loan of bank. And they got and also at that time, English bank were very generous to give loan, gave too much loan to the market, and then all people require, and I mean that the demand of coal was triple time more than the previous time. So then the coal market, I mean that the price of coal got increased, and some of them also bankrupt. I mean at the end of that. But anyway, this is a Jevons paradox. Sometimes technology advancement, and particularly energy efficiency or resource efficiency technology, reduce, actually they do not reduce the energy consumption or resource consumption. However, we have a new induction of demand. And because of the demand induction, we have more demand rather than less demand. So this is a kind of the Jevons paradox. And we name that as a rebound effect. Rebound effect means that you expected to have a better condition, but because of some relationship between different components, the result is not good as you expected before. So now, all of these questions and this actually example said that, okay, what should we do? We have to find a solution, yeah? And also we as a urban planner, scientists, faculty member, we have to earn money somehow. So we have to generate some new method to say that, hey, guys, policymaker, we have some magic box, just come with us and then we can give you some good solution. So the best question, I mean that the very important in system thinking is the stand of, actually your point stand or a viewpoint. I mean that where you are standing, yeah, and look at the which scope of the project or the problem. So I mean that if you look at this picture, it's a one person with between the two blocks, and this person actually push one block. Of course, there is no risk for this person. Just the block is, for example, in this case, is in the right hand. But if you look at the big pictures, it's a kind of a dangerous system. So very important that we have to think which scope we are talking, macro scope or macro scope. In German, it's the micro or macro. So here we have some methods that I will explain in the second part a little bit in more depth. So we need to quantify, first of all, of course, the problem is a qualitative concept, but we need to transfer that in a quantitative way. And based on this quantitative or numeric method, we can find this kind of the rebound effect, or we can have a better pick. Because when you transfer it to numbers, and if you use, also this is a very big if you use a proper method, then we can have a better pictures of the problem, and also you can provide better solution. So system dynamics modeling, it's a very also American method. It's Jay Forrester. He worked in MIT. Unfortunately, he passed away in 2016. He was originally the electric engineer, but he tried to find some solution, especially in 1950 and 1960. That time, operation research and engineers try to actually use their method for social science and such as that. He suggested system dynamic modeling to apply some engineering method in a humans, I mean that in a social science or policy making and such as that. And he got a good success. And also the system dynamics modeling is one of them. A structural equation model, SEM, it's a method, machine learning, classification, random forest, and clustering. So just this is Jay Forrester. And this system dynamics model is a computer-aided approach based on cause and effect analysis. So this is a very nice, I think that for urban planner, it's a very good method that you can think about that, because in this method, first you conceptualize your problem by causal loop diagram. I will talk about that also. And then you transfer this causality and causal loop diagram, you transfer that in a numeric way. and then you simulate your model. So actually, because in urban planning, we like to start with concept rather than with number. So it's a very, very good method that you can start from the concept, make a causal loop diagram, and then after that, you transfer your model to the numeric way, and then you simulate the result. So yes, okay. This is actually the problem articulation, dynamic hypothesis, formulation, testing, and policy formulation and evaluation. This is the method that we have here. We have this kind of the tools. So first, for example, we have system verbalization. You describe your problem in a one page, or for example, in a very short case, what is your problem? And the second, then you design the causal loop diagram, then a stock flow diagram, fit by mathematical equation, and then simulation. So when I'm talking about the causal loop diagram, maybe I can give you some. So this is a causal loop diagram. As you see, for example, you have one problem, for example, traffic problem. And then step by step, you draw the relationship between the parameters together, of course, not in a linear way, but also by considering the interrelation between them, yeah? And then gradually you develop the final models that you have, such as this case, for example, this is a problem. I think that it is also in Denver, the traffic problem in Denver. This model is developed in 2001. And just they have, for example, travel time as a put of that, and the relationship between the parameters together. And very interesting, this is from the brainstorming as a Delphi method, talking with each other from different departments, for example, economy department, infrastructure department. People talk together, and then by the standard notification and method, they develop the whole picture, yeah? After that, we, for example, transfer this model to the numeric way, and then you make a simulation and find the optimal, for example, time or in the capacity for road or other cases that you can do. So this is system dynamics model that I want to explain about that. The another method that we have here is, yeah, a structural equation model. In these models, you know that when we are talking about the human science, the first criticize that how you can quantify the feeling of, for example, risk, perceived risk, attitude, perception, love, and this kind of very concept and very, I mean, that they are a very qualitative concept. How you can quantify that? Because they are very important if you want to simulate and to see the interaction between the parameters. So we have a very good method said that this is also a very interesting method that if we have some latent variables such as feeling, such as, for example, perceived risk, perception, attitude, we can calculate somehow the degree of this attitude, the intense of or magnitude of this attitude, such as too much, I mean, that very risky or low risky, by some observed variable. So, or tangible variable. So, for example, we want to know about the feeling of you about me, for example. Of course, when you generally ask, what do you think about this guy? I mean, that's that yes, I mean, good, bad, or something like that. But if I ask, I mean, that this question, so what do you think about the content of the presentation? What do you think about the style of talking? What about the accent of this person? Or what about, for example, about you break down this feeling in some indicator. Then you measure the overall feeling, not only by direct one question, but by some, for example, attributes of this feeling. And then make this connection as a one package. This is the main idea of SEM, or structural equation model. This is a very novel model that said that you can, if you have for example, 3 or 4 or 5 different motion or emotion or this kind of latent variable, you can make a relationship between them indirectly by their observed variable, by this kind of the question. So look at that. If we have, for example, here, this latent variable is a kind of these big circles, as you see here. we do not exactly the amount of them directly, but we make the connection between them by their observed variable, by this question. And then the system calculates this correlation between them, and very nice. And it's very, I mean that now we are in data science era, yeah? So when we are data science, I mean that just making survey, making the average of weight or this survey is very not sophisticated method. So you need some advanced method to go in a depth and give you more reliable actually result, yeah? This is, I mean that sometimes you know that when you make a big survey, of course, the mean is not the whole concept. You have to look at the data distribution, the standard deviation, and such as that, and considering all of them together, and then you make a good conclusion, yeah? So these methods are really advanced to this case. Then we have a machine learning for random forest. I just give you this topic. You can find many YouTubes. Now, I mean, I'm really, I mean that this is my one sentence from me. I mean that you can remember, I mean that you can remember me in next 5 years. I will tell you, I mean that right now I tell you that machine learning skills, data science right now is very wow, it's very new. I'm pretty sure in 5 years, working with machine learning tools is like working with Excel because it's very simplified. If you look at the many YouTube clips and this kind of a Google collaboratory platform, or many actually this kind of platform, you find out that it's very easy to use this method because you should not develop by yourself. You just need to use them, yeah? So, and to understand how you can use them, it's just 30 minutes watching the YouTube, yeah, really. Of course, data preparation is another case, but just machine learning by itself is very easy, yeah? Data preprocessing and data preparation is actually the big job, yeah? It's another case. But don't be panicked when you see that this kind of, so machine learning such as random forest is a very new method that if you have, for example, 100 variables to predict or evaluate the feeling of people, then by this method, you said that these 3 or 5 are more important based on that. So if you, for example, ask people, 1,000 people or 10,000 people about their feeling about the development of one city such as New York, about this project, then 10,000 people answer, you should not just make the average and this, because always this is a big bias. But by this method, you can get a very nice that, for example, these 5 methods, these 5 parameters are more important and more, they have a more significant impact on the perception of people. And the last one is a clustering. And then I finish my talk here. If we have a time, I think that clustering. Clustering is super important. It's the last slide, but not the least. Clustering means that if you have 1 million people in your city, and if you have one project, then how you can cluster these citizens based on their perception, their feeling, and also socio-economic background. So for example, maybe, for example, you have you would like to develop one policy, put some tax as a carbon tax on fuel. So you have a different range and a spectrum of citizens with a different socio-economic background, from middle class, for example, high income level or low income level. So, and also genders, ethnic point, and also age, education, even the living style, the population density of their neighborhoods. I mean that built-in parameters and many parameters that how they use their car and such. So if you have 100 parameters and if you have 10 million people, how you can cluster them? Use machine learning clustering. So this is the question that this machine learning answer. We have some methods such as k-means and such as that if you have 10 million people, 100 parameters, how we can cluster them, that this cluster, they are really similar group of people that they have the same idea about your policy. The method of machine learning clustering is some method that we use for our social science, I mean that to understand the perception of citizens based on the project that we have, even in Europe or Germany or other places, yeah? So this is also very useful. And yeah, also, for example, if you want to develop a new project or a new, for example, here as a new product, we have a UX as a user experience or citizen experience that I can say that. So by this new product, how you can cluster of people, which cluster use more and which cluster use less, yeah? So these are the questions that you can answer by this kind of the method. Good, thank you. I hope that I could manage the time, Brian. Yeah, so now we have a time for some question and idea exchanges, yeah. Brian, maybe we can start with you. I know you. I mean,
Yeah, no, I think it's great. Thank you so much. I know, and also just so everyone knows, if you're interested in a more detailed use case example lecture that he's actually offering Archon at 1:30. I know that a lot of you have class, but I just wanted to make that available. This is a lot of information presented, but diving into the use cases is really interesting. If you'd be interested, maybe you could tell the group a little about. I know you're working with Uber right now, which is the air taxis. How is this being used? You know, to find that use case.
Yeah, actually, this project is not from Uber. It's a project between UC Berkeley and NASA Ames. I mean that they want to run these air taxis. I can say air taxi is a very commercial name also that Uber used for eVTOL. This kind of the vertical, I mean, it's a kind of a helicopter, but it's not a helicopter working with fossil energy, working with electric engine and motors. So the question is that which people will use this, and if they use, for example, what will be their expectation, and what about the expectation of other people that even they are not the user of this mode, but what about their actual expectation and also their consent? When we are talking about the air taxis, you know that the sky belongs to the public area. Yeah, I mean that of course when people said that rich people in Manhattan and so that they use their helicopter, for example, between the banks and for example, their villa outside of the countryside. But when we are talking about the public mode, such as air taxi, and of course, in the beginning of that, it will be very expensive. I mean, it's not. So what about the perception of the citizens said that, hey, when we have an air taxi, one of the problem, or in Germany, we had one project in 2021 till 2022. We had a big sample size of 1,000 people and asked them that, how do you think about air taxi system or using drones for passengers? Yeah. And do you know that the first big concerns of Germans, I mean that in this sample was, this is a blocking of sky view. And the second, the risk of falling down of these modes, yeah? Because, yeah, of course, I don't care if these people want to take the risk of the, for example, air taxi, I mean, the accident, but we are talking about the urban area. If, for example, every day or every month we have a 1 or 2 fatal accidents, it's not only people killed inside of that, but also the people around that also. So these are 2 concerns that they show up in their survey result. But of course, with this kind of the method, we use that, not only average of that, but we actually, and then we work on that if we want to make this as a public mode, that more people use it, so which factor should be, is more sensitive, I mean that, and which factor should be actually consider more, that we can get and catch more people to this. Of course, all of us, we know about the money, of course, but beside of that also we have other, for example, parameters. So yeah, reliability, time reliability, safety, environmental aspects, also the design inside of that, how should be, that's the design of that, so that people, for example, do they feel, for example, safety when inside of that there are 4 people or 6 people or only 2 people. So all of this kind of the question is a kind of the perception analysis. If you ask me, is it really realistic or planned that we will see, for example, air taxi next year? I can tell you that if there are lots of big companies in US, for example, that you know that they try to, I mean that, but if the FAA, this Federal Aviation authorized administration such as that, if they give this permission, I think that in 2025 or 6, we will see very commercial use of that in the United States, such as that. So, and then the industry and the administrator and also the policymakers should prepare themselves, because if they don't prepare, then we will see many protests, problems, that because the society is not really ready to accept this model. Just remember how Uber, how many problems did Uber have, even in different countries, that some people kill each other. For example, in South Africa, you have heard about this many. So just think about that what will happen for air taxi if you see that it's a very high frequent use of this in urban area. Yeah.
So as planners, we're always hungry for data. And there's an increasing number of private firms out there. We have Sidewalk Labs, that's part of Google, and their spinoff, Replica. There's a number of others. So using this kind of synthetic data approach. So they're homing lots of big data sources. We're not even sure exactly what goes into their data. And there's some real potential, I think, for that to help us as a profession. But also there's been some pushback and some concerns around reliability, ethics, a number of things.
Data
So
protection.
I guess I'm just curious where you sort of the potential you see, but also the pitfalls that you see, especially as planners, where we're really kind of we're supposed to be on the side of kind of the public and protecting that.
Yeah, I mean that. Thank you very much for this question. I mean that normally we use with the data of the survey that the participant, I mean that is a kind of, in German, the freiwillig, is a kind of the voluntary participation. So it means that people accept to participate. And we have a two types of survey. The survey as a kind of the confidential, the identity of the participant, or for example, even it's very without any name or address, but general overall. So we take also, you know, that in Europe, the personal data protection is much, and again, much stronger than US. So it's a big problem, and also a very headache. I mean, not a headache. I mean, it's very good also. But anyway, the type of the data when we are talking about the perception is a very data about the feeling of people. So when you are talking about the Google, they are a kind of the aggregative data, such as a movement of the, for example, people or objects or such as that it's very nice. But when we are talking about the feeling, even, for example, maybe, for example, social media such as a Facebook, by tracking of the number of the click, such as the this empirical college, I forgot the name of this big scandal during the for the election of 2020. But no, I mean that this kind of platform cannot find a very direct parameters about the feeling and perception and attitude of people. So I believe that survey and the questionnaire, which are designed in a very appropriate method, and is the best way. And when you have this kind of a question, of course you need the first permission of the people, because people should agree and committed to fill that. So if you follow this method of designing a good questionnaire, inviting the people, get the permission, we don't have a personal permission. But if you want to go to the social media, tracking of the behavior of the clicking of people like that, but good news that real feeling of people is not really, you cannot reveal that by this kind of the method, because maybe you click somehow, statistically said that this person clicked 10 times more A rather than B, so it means that this person has more tendency to use A. But if you want to know about the risk attitude, perception, you need a really direct question. And that, so I think for urban planner, this kind of the questionnaire is not a big problem. Yeah, please.
Yeah, I have two, I think, interrelated questions. I hope they come across like that. So the first one was kind of around complexity. So with all these models I've played with before, you get really complex really quick. And that's, almost makes it not useful then, because no one can understand it. So then kind of related to that, I know there's a bunch of different metrics or things you can use to say we're having diminishing returns and adding new variables, things like that. But I think there's a lot of concern around that for me, at least, or other folks, because it's like, what is the role of the researcher then? If we're just going to automate everything, like how do we use theory and what do we continue to do? So I guess like, how do you think about those two things?
Thank you very much for this question, because at the end, if you want to earn money, you have to sell your model, and people should understand the model. Yeah. So honest, I mean, let me just give you this actually with this example here. Among of this method that we have here, for example, if I go there, yeah. So of course, for example, the outcome of these models and this model, of course, the name of them is a little bit fancy, but the outcome is very easy to understand, because you said that which parameters are important. And you, for example, policymakers said that A, B, C, D are important. Then they ask it why, and then you show the model. And then it's more complicated enough to say that, yeah, that's enough. Okay, you got it. But I mean that, as I said, that random forest or classification or classing, at the end, the result is the outcome is very understandable. But you're asking that, what about the complexity? Of course, for all of these models, these three models, all of us, we have some assumption that because of this assumption, we simplified our model. And then we are talking about the human or person as a very black box, I can say. We cannot really predict precisely. But anyway, this kind of the method are really in the market or in the research field, I can say that are better than the former methods. Yeah. So maybe, and the second point, don't forget that we don't claim about the prediction. We are talking about the association between parameters. We are talking about the correlation between them. So it means that I cannot tell you that this specific person will do A or B, but I can say that, for example, if this person smoke, or if this person, for example, have a bad diet or such as that, most likely is going to die. That's most likely doing that, such as that. So it's a kind of although it's a kind of the prediction by the closed eyes, but anyway, these methods are much better than other methods. And honestly, I mean, I think the outcome of that, I mean that in Germany, I mean that when we have, it is acceptable, yeah? Because now also for policymakers, I think that they need some numbers. So you have to provide good numbers and better method. I think that these methods work very well. Yeah.
I really appreciate you bringing up the paradox about energy use. And one of the things that really struck me when I heard about this is that even as we bring on all these electric vehicles and this move to an electrical powered system, we're not decreasing our fuel consumption, we're actually just increasing it. Like every new technology just keeps increasing it. And since humans can't seem to figure that out, and I'm wondering, like, as an urban planner, are people using these machine learning methods to actually figure out a way for us to reduce our consumption? Like, is there a way for that to happen?
Yeah, I mean that first of all, my PhD thesis was about this case that technology by itself cannot promise you to have a better solution. It depends on the society and the context that you apply. In my thesis, I showed that, for example, about it was in the very early time of Uber time, and I said that Uber has a negative impact in these cities because of these urban parameters, even the built environments such as density, intersection density, or node, I mean that the type of the urban form plus the socio-economic parameters. Uber has a bad impact that people use more car rather than public transport or walking, but in other contexts, it has a very positive, people use Uber in connection by other modes. So it's a kind of a deterministic thought that, hey, this technology by itself is not wholly or very useful, but the context that you use shows whether it is good or not. So about the Jevons paradox, so it's just about this electrification. For example, we have a right now big challenge in Germany about the electric car. So you know that the government spend lots of money, even they have some subsidies. I mean that the money, for example, if you buy a Tesla, till September 2023, this year, you can get €4,500. Last year was 6,000, and this is. Then also we have such as a CO2 quota. It means that every user of electric car, they can get €400 per year because they use electric car rather than the fossil car. So now this CO2 quota, or this such as that, I don't know, or CO2 benefits such as that, the big companies such as Volkswagen, such as Tesla, said that, hey, users, you can transfer this €300 to us, and they gather all of them from the customers, and as a big package, they sell to governments, such as we are talking about $1 million or euros. I mean, that is a big money. Now, instead of that, this car manufacturer offered 3,000 free supercharge in Germany. For example, Tesla offer, if you give us or transfer this right to us, every year, for this year, you have a 3,000 free charge, supercharge from fast chargers. Germany, 54% of electricity is coming from fossil and coal. Imagine that, and now actually, my wife, we had a Tesla, and I said, hey, we have a 3,000 free. We can go to Prague and then go to Vienna and then go to this, because all of that's free, Hamid, just go. And then, no, just go, and then it's free. So, and we made it, unfortunately. And then I said that, hey, if there was not 3,000 free fast, I've never had done this, I've never done this trip, because I said, hey, it's almost, we are talking about, for example, €600, for example, just for example, that is. So it's a kind of induction, induction of demand. So machine learning, I mean that this is a kind of the method that you can use in this kind of method to kind of rebound effect of electric. Even it's a very hot topic right now in this year. And we have a PhD thesis in this case as well. Yeah, sorry.
No, I just wondered if there were any questions in the comments. I see you.
Yeah, so then I go to the comment. Yes, please.
Yeah, I'm sorry, I want to jump in because we're at 12:52, so we're going to take one more question, then we're going to need to wrap up.
Oh yeah, so can we have two questions, one from the online side and one from here in this class? So from the online side, we have
Maybe there aren't any questions.
So before that, we go to your question, and if there is a question, then you can come. Yeah, please.
I've got two questions. One is, nice if you would define machine learning.
Right.
To me, that tree diagram was not machine learning.
No, yes, of
because
course.
there's no feedback. So it seems that simplified version is just talking about automation or optimization or something. The other thing with the dynamic modeling, I understand the need to simplify the models because it's just do
Yeah.
you guys ever do actually, it doesn't seem dynamic.
Yeah.
You know, do you ever actually do dynamic models and actually
Actually, I keep some of these topics for the second part of the class in details, because I know that in the 50 minutes, I said that these are the methods that we use. But about the machine learning, first of all, as I said that the definition of the machine learning, I have the presentation, the next part, that how we can use machine learning and what's the meaning of that. It's a kind of the learning by error. Very simple. If you ask me what's the machine learning, I said that how machine can learn by error. And of course, when I said that the error means that first you have a target, and then every time you have a function to calculate error. But very simple in this case, that instead of in computer, instead of, for example, the algorithm, so for example, by thousands if condition, you can define some method that machine just try an error and just said that how can I minimize my error? That's the concept of machine. So now when we are talking about the 10 million data of 10 million people, and for example, we said that find 10 clusters, machine tries to make a cluster, and then by this error that you define, tries to minimize this error. Maybe the error is a similarity. Maybe error is a specific point, yeah? And then machine tries by try and error to find the best fit. I will explain the second part. About the dynamic system, the dynamic means that the parameters which are dependent to time. So it means that the relationship and amount of the relation can be changed by time, and how we can determine this change per time. So actually, we have this equation to make a real dynamic of that. So in our definition, dynamic means that define the relationship based on time-dependent variable. If the parameters are not time-dependent, it's a statistic. But let's talk about that the next. Yeah, I think, is there any question from online platform?
Check online, yeah. So as he was mentioning, we have a second part of the lecture. I know you all have to go to class, so if you can't make it, it's totally understandable. But if you are interested in learning more and diving deeper, we'll be up in Archon from 1:30 to 3. So if you guys can make it, and also for Zoom, if you're on there, we're going to be using the same link if you're interested. So I don't think we have time for questions because people have to go to class. So thank you all for coming. It was nice to see you all, and thank you, Doctor.
Thank you very much.
Very good.
Very appreciate for your time.
Thank you. Yeah.